presentation with Peter. Thank you so much for joining us and for
Thank
stepping
you.
in short notice for this.
Normally I experienced acute imposter syndromes when I speak publicly. Today it's super acute because I'm not Kirill. I'm Peter. Apologies, my colleague and our founder Kirill, he couldn't make it, so he told me about it like 6:30 a.m. today. So I tried to fill in. What's E184? Essentially, we're a mothership for a host of 3 types of activities. We support field buildings, summer schools, hackathons, workshops. Sometimes we invest, we do equity investments, but that's not the focus. What the focus really is we spin out, we launch and fund privately funded research labs, borderline basic science research labs within 2 focus areas. Area number 1, reproductive technologies, things like IVG, different components of ectogenesis stack. So that's one thing. And my thing is neurotechnologies. To be more specific, we are working on BCI. And what's our premise there is we do believe that we will get to this AGI or strong AI. So the question is how to deal with it, how to live with it, how to collaborate with it. Obviously, there are multiple types of efforts, right? We can slow down the development of AI, we can make it more, aligned, etc. But we believe there is another strategy, which is to build really an interface, scalable interface to collaborate and to work with AI. I'm sure most of you have seen slides like that. So when you start to think about this interface, you bump into a problem that, existing technologies, existing paradigms, they are either not performant in terms of spatial temporal resolution, like EEG, FNIRS, fMRI, or they are implantable and therefore, in our view, not scalable. They are kind of scalable if you think about millions of people maybe, but if you want to scale something to hundreds of millions of people, or maybe billions of people, what could it be? So we are stuck. With this chart, we are kind of stuck in a similar way as the community, right? We needed a transformative moment. I think Amy mentioned this transformative moment. So from our perspective, and what sets us apart is that we have time, resources, and commitment to go deeper and analyze, like what magnetoencephalography exactly means, what physics is behind, and what kind of alternative approaches may exist there to transform these modalities into better performing ones. So I wanted to share something with you that's like a part of our kind of workings, really blurred up a bit, sorry. We looked at hundreds, or a bit more than 100 of different sensors. So for many folks, let's say magnetometry or magnetoencephalography is generic, it's magnetoencephalography, but there are a couple of sensors there that already are deployed, and there are dozens sensors more that could lead actually to better results. So what we have done in the last year internally and with a bunch of advisors, we looked at like almost 100 of sensors. So we built this conviction on magnetoencephalography. Oh, sorry. It's quite a nice modality, right? It works directly with neurons. It has nice temporal and spatial resolution. And what's important, there was already some progress there, right? So if you look at Squid Mag, superconductive mag, it's like huge machine, non-portable at all. You have cryogenic cooling there. So it's a nice machine, but not scalable. Then we have OPM mag, optically pumped mag. That's super cool thing. You can do naturalistic behavior with them. You can use it on kids. There is one challenge. It's in magnetically shielded room, and the room is like 7 tones or something like that. So not scalable at all. Very good for experiments. I would encourage you to look deeper into OPM mag if you want to do some naturalistic experiments, especially with kids or with multiple people interacting. So there were already setups when people were doing like interaction, cognitive tasks, playing with each other, etc. with OPM mag. And therefore, our mission right now is to launch a lab that will work on magnetoencephalography 3.0. So what will be the next thing? If there is a next thing, right? Can we go beyond magnetically shielded room? So hopefully within a month or so, we will launch the lab and tell you more. What we have done so far, and I wanted to say thank you again to Neve and Alison for the format. We invited someone to speak about, I would say, beautiful and elegant ways to measure magnetic fields. So Gavin, raise your hand if you would. He's speaking tomorrow about, a bunch of interesting sensors that are beyond the existing neurotech kind of landscape. And we think that the next frontier will come kind of outside neurotech directly, maybe from chemistry, maybe from material science, maybe from somewhere else. So I would encourage you to kind of have a look at what Gavin has to say, and you can find me today in Amygdala. It sounds funny. You can find me in Amygdala to talk about anything non-implantable, scalable, interfacing. Thank you.
Oh, thank you.
Thanks, Peter. That's very exciting. I was wondering, are you able to share that kind of review that you did? Because I think that's hugely beneficial, and it's something that doesn't really exist. So like, you know, just the slide you shared there with the 100 different sensors, and I assume you did like documents and, you know, more details about those sensors, pros and cons, path to scaling. Like, I feel like that's a resource that would be super useful. So
we are thinking about what kind of stuff we can share. Yes, we did this quite detailed review with quite specific, you know, specs and parameters for each sensor. I think we'll publish something, but I can't tell you exactly right now to what extent we will be able to open up this work. We really spent around a year looking at around like bunch of sensors, but we'll definitely publish something. Yeah.
Anyone who hasn't, I'm going to go over there because he hasn't asked a question yet.
Very cool. Are you just trying to get rid of the shielded room, or do you have ideas for how to improve things like resolution?
I think that would be my wildest dream to do simultaneously. But even if you look at the current Mac, I think we can get to millimeter resolution, like 5 definitely, like maybe below 5 millimeters square.
At the cortical surface or below?
Oh, cortical surface right now. Yes, there are some attempts. I know that folks work on what is called like laminar Mac to distinguish between layers in the cortex. I think I'm a bit wobbly on that. I'm not sure if somebody did a lot of work on Mac for subcortical structures. If I can get to scalable sensor for cortical surface without magnetically shielded room, I think it's already like a good thing.
Okay, agreed.
Logan, we have time for you. Thank you.
So I was wondering, it sounds like you have a pretty strong focus on this MEG stuff. I was wondering if E184 has any other has interest in funding other areas of neurotechnology. I wasn't entirely clear on like how much of a focus it is currently. I know a lot of us are interested in ultrasound approaches, so things like that.
There is no kind of formal limitation, so we can work and, you know, support pretty much anything that hits our end goal. So we are about supporting and developing super scalable recording BCI, right? But so far, MEG is the focus. It's our first lab. We will work on that so far, taking one step at a time. I'm sure there will be an expansion at some point. But again, it's something that could happen. We don't have, you know, formal limits or anything like that.
Excellent, thanks.
Thank you.
Cool. Thank you. Thank you so much.
Thank you.